So after constructing a calculated column that works as an indicator for the rows at the end of each month, now we can introduce this measure that calculates the moving average of the closing price in the prior 12 months. Okay, so we do that by going to, you can go to the table tools, or you can go to the home tab and click on the new measure. And I'm going to paste my DAX code here. So this measure, I call it MA_YM, standing for moving average year month. Basically, I'm only taking the moving average for closing prices at the end of each month. Okay. So the first step, I'm defining this variable called EOP, standing for end of period. Okay. So basically, I'm using this filter function to work on this historical daily data, and I'm not taking all the rows from that data table. We're only taking rows in which the column that the column called EOM1 has a value of 1. Basically, well, as we learned before, the calculated column EOM1 will have a value equal to 1 if the trading day on that row turns out to be the last trading day of the month. Okay, if the trading day on that row is not the last trading day of the month, then this EOM1 is going to have a value of 0. So basically, we're taking all the rows whose EOM1 equals 1. Basically, we're taking all those trading days at the end of each month. Okay, so this is going to be the EOP table. It's a subset of this historical daily table, which only contains rows related to the last trading day of each month. Okay. Another thing you need to notice is this all function. I apply an all function on the historical daily table. The reason is because we're constructing a measure, and measure is going to be shown in a variable. In a variable, there's always a filter context. For example, if you have a line chart, and x-axis is going to be different dates, then each date on the x-axis is going to work as a filter context, and that filter context is going to be applied to whatever data you are using in this measure definition. So without this all function, if I'm only using this historical daily data here, then by default, the filter context on the x-axis is going to be applied to this historical daily before this measure starts to do the calculations on the data. Okay, so for each date on the x-axis, for example, if the current point on the x-axis is, say, March 9th, 2023, then all the data this measure is going to use is only going to be related to March 9th, 2023. Okay, because March 9th, 2023 already worked as a filter to filter out data from this historical daily table. So we're only left with data related to March 9th, 2023. And the measure is going to work on this filtered data to do the calculations. However, here we're not just calculating a price related to that day only, right? We're trying to calculate price using information from the last 12 months. So definitely we don't want the filter context to filter the historical daily data before the measure starts to do the computation, right? So using the all function, we basically ignore all the filter context embedded in the variable. So regardless which particular point you are looking at on the x-axis, the measure calculation always utilize the entire historical daily table. Okay, all the rows in there is going to be used in the definition of this measure. Okay, there's no more filter context you need to worry about. Okay, so then next step, we define a kind of a parameter which is used for the window length in which you are going to calculate the moving average. So the common choice is 12. We're going to use the prior 12 observations to calculate the moving average. Okay. So next, we're going to use the window function to retrieve the 12 observations prior to the current observation, and we're going to average those 12 observations to find the moving average. Okay. So here again, realize we're working on a mirror, and this mirror is going to be using a zero. So in a zero, there's always a future context. So the window function actually rely on the future context to decide what the current row is, or what the current partition is. Okay, so the window function again use the match by clause to confirm that this historical daily data is identified by stock symbol and date. So each observation in that data set is a particular stock on a particular date. Then currently we're going to partition that data set using stock symbol. So each stock is gonna form a partition, and all the trading days related to that stock is gonna be the rows in that partition. Okay. Then within a partition, the order by again is gonna order those trading days within a partition in ascending order. So for this particular partition, say Apple, we're going to have trading days starting from the first trading day all the way to the last trading day for Apple. Okay. And next, if we move on to another stock, is again all the trading days for that stock is going to be ordered ascendingly. So based on this rearranged or resorted data set, we're going to retrieve the following rows. Okay, we already defined n before n equals 12. So pretty much what we're doing here, we're trying to retrieve a set of rows relative to the current row. Okay, the REL stands for those rows we're trying to retrieve. Is going to be we're going to use the relative positions to retrieve those rows. Okay, so what do we mean relative? Relative to the current row. Okay, so here the current row is determined by the future context. If we're looking at this point on the x-axis, which relates to the last trading day in March 2023, then the current row is basically the last trading day of March 2023. And we're going to retrieve, okay, starting from, because n equals 12, so we're starting from 11 rows prior to the current row. Okay, we're going to start from 11 months before March 2023. And the last row we're going to retrieve is going to be 0 row relative to the current row, okay, which is the current row itself, March 2023. So pretty much what we're trying to retrieve is a range of rows starting from 11 months prior to March 2023 all the way to the current row, which is March 2023. So all those 12 months are going to be retrieved from this EOP table. So those 12 rows we just retrieved using the window function is going to be stored in this variable W. So W contains 12 rows. Those are the 12 months prior to the current row or the current month. Okay. Then the average X function is going to work on those 12 rows, one row at a time. For each row, the function is going to take the adjusted close for that row. Basically, that's going to be the closing price of the last trading day of a month. Okay. So for the prior 12 months, we're going to get 12 closing prices at the end of the month. Then we take the average. So average X function is going to take the average of those closing prices at the end of the months for the prior 12 months. And this average is going to be assigned to the mirror as the moving average related to the current row, which is March 2023. So after we calculated the value for this mirror, okay, when we're standing at March 2023 on the x-axis, we're going to move on to the next point on the x-axis. Suppose it's April 2023. Okay, so for that point, the calculation of this mirror is going to repeat just as what we did before. Okay, so we're going to, the window function is basically taking 12 months prior to April 2023. Okay, including April 2023 as well. Okay, all those 12 months are going to be taken out and the average function is going to calculate the closing price at the end of those 12 months, okay, and take the average of those 12 closing prices and assign this average value to the measure, okay. So when we stand at April 2023, this measure is going to equal to the average closing price in the prior 12 months relative to April 2023. So next, when we move to May 2023, again, this measure is going to take 12 months prior to May 2023 and calculate the average closing price at the last trading day in those 12 months prior to May 2023. So, and so on and so forth, we're going to get for each particular month on that x-axis, we're going to get the average closing price in the prior 12 months. Okay, so that's how this moving average measure works. So we have constructed this moving average measure for monthly frequency. We can now just put this in a line chart. So we want to have now, because we're looking at the monthly frequency, so we're going to use this year-month data field under the probable date table as the x-axis. Okay, and for the y, we're going to have the closing price at the end of each month. So we're going to use this last adjusted close measure. And once this measure is applied to this zero, and each data point on the x-axis is a particular month, then for each month, this measure, last adjusted close, is going to show the closing price in the last trading day of that given month on the x-axis. Okay, so that's going to be the monthly closing price over time. So lastly, let's just have this monthly moving average also included in the graph. All right, so this is going to be the average of the closing price in the prior 12 months, including the current month. Okay, so compare with this graph, which is the daily frequency. You can see this is daily frequency and daily moving average. In this graph, we have monthly frequency, closing price at the end of each month, and their 12 months moving average.